Imagine you have a particle moving through space according to a vector function r of t. At any moment in time, we can calculate the direction of motion, big T, the principal unit normal vector, big N, so t is pointing in the direction of motion, big N is pointing inwards to the turn, and then that mutually orthogonal vector, t cross n, or the binormal vector. For every point in space, this defines a right-handed coordinate system for that moment in time. You can actually think about it as kind of traveling with the point as you move along a curve in space. That's called the Frenet frame, and it's an important characteristic of describing particles in motion. You'll also see it referred to as the T and B frame. The different planes in the Frenet frame all have different names. If you look at the Tn plane, the one that's kind of the floor, that's known as the oscillating plane. Not the oscillating plane, the oscillating plane. What happens in the oscillating plane is the curve just comes up, and in that moment, it's like the curve's trying to be in that plane. Oscillating, I think, comes from a Latin word for to kiss, and it's like my function comes up and just glances through that plane. All right, the B and N planes, or excuse me, the BN plane is called the normal plane. Well, that's a good name for it. That's the binormal vector and the principal unit normal vector, a whole lot of normal things going on. And then finally, the plane determined by the TB vectors, the TB plane, well, that's called the rectifying plane. And we can actually find any of those planes using the third vector, right? If I want that Tn plane, I need to know a point on the plane from r of t and a vector perpendicular to it. Well, that would be big B. If I want to find the Bn plane, I need that same point and a vector perpendicular to the Bn plane. Well, that would be big T. And similarly for this one, the vector perpendicular to the plane is big N. Okay, curvature. We've calculated curvature. And one nice way to think about curvature is that it is the rate at which the normal plane turns, right? Literally measuring how this plane spanned by normal and binormal curves turns as the particle moves. In chapter 13.5, there's also a calculation called torsion, which calculates the rate at which the oscillating plane turns along t as the particle moves. We're not going to go over that calculation this semester, but you might see it pop up in a physics class or in a math class down the road. But for now, that's the Frenet frame.